Hi, I'm Karthik. I'm here to talk about fruit pellet, a revolutionizing fruit harvesting drone. Fruit pellet does fruit harvesting with vision-guided autonomous drones, reducing labor cost and increasing crop yields through precise plucking. The next topic is about the business problems. The fruit plucking is a very labor-intensive process. Traditional harvesting is labor-intensive and very expensive. The labor accounts for the up to 70% of crops of the product yield. Labor shortage is very difficult to find seasonal workers. It's very because it's very hard to work in very hot and very cold conditions. This may affect many regions globally. Crop waste. Inefficient harvesting leads to crop loss. It is up to 20% of the crops are wasted every year due to this inefficiency. Users and roles. Who benefits from the drone plucking? Farmers and owners benefits from the reduced costs and increased yields. They oversee drone operations and data analysis. Farm managers directly manages deployment and monitor progress. They schedule flights and optimize routes. Technicians responsible for drone maintenance and repairs. They are very important for drone management. They important checks and troubleshoot issues. Data analysis analyze harvesting data to improve crop management and do strategies. This is a system architecture diagram for your fruit plucking drone project. User interaction. User accesses the system through a web dashboard. The dashboard interacts with the cloud server, allowing the users to control the system. Drone system and YOLO model. The YOLO model detects fruits and sends process data to the drone system. The drone system navigates the farm based on fruit detection and communicates with the IoT sensors. The IoT sensors gather data on fruit location and harvesting conditions. The actuator executes harvesting and sends data to the database. Data flow on the cloud sensor server. Sorry. The cloud server processes data from the drone and IoT sensors. It also stores and retrieves data from the database. The web dashboard accesses the data and provides real-time monitoring for the users. Database and storage. The database stores all the collected data, including harvested fruit records and sensor data. The cloud server provides data access for different components. The key functions of every part is ULO detects the fruits, drone movements and scans the farm. IoT seasons, IoT sensors create navigation and collects data. Actuators control harvesting based on the processed data. Data is sent to the cloud and stored in the database. Users monitor and control the system through the web dashboard. The next is about the dataset and processing. So for data pre-processing approach, we first does the verification and validation. We remove the duplicates and incorrect labels, and we does the normalization. Resizes images, adjust brightness for varying lighting conditions. Data augmentation, rotate, flip, and adjust images to improve YOLO model accuracy. Label encoding, classify the fruits into ripe and unripe categories. And for the processing, they capture the image. Drone captures images of fruit trees, different fruit types and ripeness level included. Object detection. YOLO algorithm identify the fruits. Real-time object detection with high accuracy. Ripeness assessment. Computer vision analyzes the color and shape. Determines fruit ripeness via OpenCV. Path planning. We have to give the path planning for the drone to correctly access the fruit. The tech stack used for the food pilot is front-end. Use HTML, CSS, JavaScript for the web app. Real-time status and data dashboards. Backend. Use YOLO, OpenCV, TensorFlow for the drone control and data transmission via ROS. Hardware. Onboard computer for real-time processing includes camera and robotic arm. Deployment. Testing in controlled environments. Pilot programs in commercial orchards. Thank you.